Okay, so here's the next big thing, and this is this process of dimensional analysis. So when you look at how I approach teaching physics, is that you all understand physics. You understand that if I hit my hand really, really hard, that's going to hurt. You understand force equals pain, okay? You get that, all right? You get it. But to understand physics and do physics, there are certain skill sets that you have to have. One of them that's very important is this process of dimensional analysis. Now, from this side of the table, it's a tough sell, because there's a couple of things that drive you crazy about dimensional analysis. One is that your calculator will do you no good, okay? This isn't plugging numbers and having your calculator speak to you as the oracle, and it says, oh, the answer is 0.055, ooh, and the angels sing. No, okay? Your calculator will do you no good. The other thing, and this is even more painful, on Monday morning at 8:25, I'm going to say the T word. It requires thought.
No, no.
Say it isn't.
It can't be true.
I know, painful as that is, okay? So between not using your calculator and having to think, it's tough, so. But here's the story. Dimensional analysis is a process, okay? It is not memorization, it is a thought process. So what dimensional analysis forces you to do is to look at mathematical operations not only in terms of just numbers, but what happens with units. Because having taught this on 2 continents for a long, long time, I promise you, you would be amazed at how many silly mistakes are made just because kids don't pay attention to the units, okay? So like one of the things you're going to do is calculate the time it takes the Lunar Command Module to go around the moon. I've got answers longer than the universe has existed, down to 0.05 seconds, okay? Not all because they don't pay attention to the units. Now, plugging numbers into a calculator, you all are great at it, okay? You are great at plugging numbers into a calculator. But that isn't the point of the story. The point of the story is that, hey, do the units actually work out to get what I get? Eventually, you all are going to be dealing with very, very, very complex equations. And the sooner you embrace this idea of paying attention to the units, better off you're going to be. So let me give you a simple example. Could I do this? Could I take 5 meters and add that to 2 meters?
Sure.
Sure. I would get 7 meters, right? Now, could I take 5 meters and add that to 2 meters per second?
No.
No. Now, your calculator will lie to you, because your calculator doesn't understand dimensional analysis. If you take 5 plus 2, and you all do this in your calculator, and your calculator would tell you the answer is 7. Don't act like you wouldn't do that. You would do that. You would do that in your head on a dip. So, you're going to get 7. But then, here's what's going to happen. I've seen this happen more times than I can even begin to think how many times it's happened. But you all sit right down and go, oh, Mr. Burkamp, don't be silly. You can't add meters to meters per second. I see it happen all the time, okay? You try to add unlike units because you don't pay attention to what happens up to that point. You just see 5 plus 2, you plug that into your calculator says the answer is 7, you read the question and go, oh, Burkamp wants a velocity, I'll put meters per second on the end of it, okay? I know this, okay? I'm psychic, I know what's going to happen. And then I'm going to snarkily write on your paper, really? You took meters and added the meters per second. I'm going to hand that back and you're going, oh, man, okay? And then you're going to feel like a schmuck. Pay attention to the units. It's going to save you a lot of heartache as you go. I know the future. I know what's going to happen. Now, could I do this?
Going to do it first. Okay, it's going to be going.
Could I take 5 meters and multiply that by 2 meters?
Sure.
Yes.
Yeah. Mm-hmm.
And I would get
For 10 meters.
squared,
Squared, yeah. Mhm.
right? Otherwise known as an area. Okay. Oh, I got a dimension that's 5 meters by 2 meters. Oh, it's an area. So I can multiply. Here's what you need. If I have the same units, I can multiply them. I could also add or subtract. Okay, cool. Now, could I do this? Could I take 5 meters per second and multiply that by 2 seconds? Can I multiply together, Matt, unlike units?
Yes.
You say that with absolutely no confidence. Your answer is right, by the way. I can't. What am I going to get?
10 meters. 10 meters over seconds squared.
You should have stopped when you were ahead. And here's the reason why. This is what happens in dimensional analysis. You're taking meters per second, right? And you're multiplying that by seconds. So what's going to happen to the seconds?
Oh, it's canceled.
They're going to cancel out. You're going to get
10 meters.
10 meters. So I can multiply together unlike units. Because this is what we're saying. Oh, I'm running at 5 meters per second, which means every second that goes by, I'm going to travel 5 meters. I'm going to do that for 2 seconds, so therefore I'm going to travel
10 meters.
10 meters. Okay?
Neat.
So what happens in dimensional analysis, it isn't just, oh, I'm going to type into the calculator 5 times 2 and get 10. But now I'm going to go, oh, right, hey, I'm going to get meters. Now, so I can't add together unlike units, but I can multiply unlike units. But when I multiply unlike units, I change the units that I have at the end. So here's what's happened. I took a velocity, one of the derived units, multiplied it by time, one of the fundamental units, and I get another fundamental unit. So I multiplied meters per second by seconds, ended up with a whole new thing of distance. Okay? Go with that. Now, could I just take 5 meters times 2? Well, could I just take 5 meters times 2?
No.
Really? I'm going to give you 2 boards, each 5 meters long. You're going to stack them end to end. What's the total length of the boards?
10
What?
meters.
There you go. So can I take 5 meters and multiply it by 2?
Yes.
Yes. And what are you going to get?
10 meters.
10 meters. Because if this doesn't have any units, that doesn't change that. Okay? So I can multiply that. Okay. Trig functions, right? Anybody happen to remember the numeric value of the sine of 30?
5 or 6.
1/2.
Oh, sine of 30. I'm dumb. Very.
Sine of 30 is 0.5. Could I take the sine of 30, which is 0.5, and multiply that by 16 meters per second? And what would I get? Sine of 30 is 0.5.
8 meters per second.
Beautiful. 8 meters per second. So, okay? So if I multiply by the sine of 30, that doesn't change the units at all because of the fact that it's just a numeric value. It's 0.5. Okay? Let me see. Could I do this? Could I take 5, no, let me make that 6. 6 meters per second and divide that by 2 seconds?
Yeah.
Yeah.
Yes.
Yes. Would the seconds cancel out and I would get 3 meters?
No.
Absolutely not. Why?
Because you have your
Double funded element.
inverse thing. Reciprocal. That's
Reciprocal.
the word. Reciprocal.
The reciprocal of seconds is 1 over seconds, and you get meters per second.
Squared.
Squared, winner, winner, chicken dinner. Okay? Right? You did not fall for my evil trap. Congratulations. Because this is what
Yay.
happens most. You go, Oh, seconds cancel out and you get meters. No, train wreck, bad,
I
stop,
see 2
go.
seconds on the opposite side of the line thingy, so they're all gonna disappear.
Yeah, no, bad.
That's the logic.
I'm just telling you. Okay,
Magic trick.
I will do that.
so, we're gonna kind of work through this assignment together.
Witchcraft.
And it's on a nice calming blue paper.
Do you choose the colors?
Breeding bird. Ooh, colors.
Do you choose the colors for
Yeah.
papers?
Huh?
Do you choose the colors for papers?
Yeah, I kind of do that.
You will get very used to the
Well,
colors.
because it also makes it easier for me to keep track of. And it's like, oh, here's this assignment. If I land everything off on white paper, then they get shuffled. And so
Diabolical world.
part of it is that
dimensional
it's soothing.
analysis.
Part of it is also, it makes it easier
It's
for
quite,
me to deal with it. Okay,
it's quite diabolical.
all right, so
Bird is.
let's get the party started. So up there at the top, all you have to do is put in the units, okay? For time, distance, all that good stuff. Now, let's talk about the force, because there's 2 options for the force to be with you. So what's one option for the units of force?
Newtons.
Newtons, okay? You can just put a capital N, okay? That's option number 1. And sometimes it's handy to use that, okay? Sometimes it is. Now, if you're not going to use newtons, and force equals mass times acceleration, okay, it's the simplest way to calculate force, mass times acceleration. There's a whole bunch of different ways to calculate force, that's just the simplest. So if I use mass times acceleration, what units do I get? Or
Kilogram meters over second squared.
kilograms meters over second squared, okay? So that's your other option for force. Either put newtons or kilograms meters per second squared. When you're doing dimensional analysis, and I'll show you how all this works, a lot of times it's handy to use the kilograms meters per second squared if you're trying to get things to cancel out. But if you're just doing like a graph like you all just did, and it's slope, oh, it's just newtons per meter. Just leave it as newtons because that has more meaning. Oh yeah, it's how far it stretches per, it's how many newtons it takes per meter, or meters per newton, whatever that is. Okay, cool with that. Now, so down here in the middle section, I've given you a summary of everything that we've just talked about. Okay, so middle section is just a summary. Now, let me emphasize this again and again and again and again and again and again and again. Dimensional analysis is a process. It is not just writing things down and then a miracle happens and then here's your answer. Okay? You're trying to convey to me through this process, hey, this is what we're going to do. Now, I promise you, amongst any number of things, this isn't something we're going to talk about today, Monday, August 19th, and then we're never going to use this again for the rest of the class, and I'm just using this to fill time. This is absolutely one of the most vital skills you've got to have, okay? We're going to do this every time we introduce new equations, okay? And we're going to be dealing with some very, very complex equations. And literally, I'm telling you, the sooner that you embrace this process, the deeper your understanding is going to be. Because then you're going to go as, wow, thinking it's a process, just not getting an answer. Okay, so that's the leap of faith that you have to take. All right, so here's what I want down on number 1 down below. So you've got VT. So you've got a blank, you got a blank. The first step that you do is you substitute the units into the equation, okay? So Danny, I've got VT. What's my velocity going to be measured in?
Speed or seconds, meters per second.
Thank you.
Yep.
That was a struggle.
Yeah.
And then you're going to multiply that by time, which is in
Seconds.
seconds. And I'm going to put that as seconds over 1. So now, when I do dimensional analysis, I like to stack my fractions like in a column. You can do like meters per second times seconds, but I found if you write them out horizontally, kids make more mistakes because then they look at this and go, oh, that's seconds times seconds, and oh, that's meters per second squared. Whereas if you stack them vertically, it's easier to see how things cancel out. Just a general word of advice. Take that for what it's worth. Now, math. When I take meters per second times seconds, what do I get?
Meters.
Now I get meters because those cancel out, and I get meters. Okay? Cool with that. Now, when you do number 4, you're going to do all of these. I'm just going to kind of point out some things on the difference between number 3 and number 4. So number 3, I have AT, right? I have acceleration times time. Preston, what are the units for acceleration?
I don't know. I don't know that.
Okay, got a big sign behind you? F equals ma. Look up above. What do you have for the units of force? Preston,
What?
blue sheet.
Oh.
What are the units of force? Newtons or what? Kilograms, meters per
Second.
square,
Oh, square.
right? So there's my mass. Here's my acceleration. So acceleration is going to be in meters per second.
Square.
There you go. Okay? So, I've got an acceleration in meters per second squared. I'm going to multiply that by time, Preston, which is in what units?
Oh, second.
Seconds. That was an easy one. Come on, man. Work with me here. So, here's what's going to happen. I got meters per second squared times seconds. So what's going to happen here? I'm going to cancel out all the seconds or only one of the seconds? Only one of them. So therefore, that's going to cancel out, and I'm going to get meters per
Second.
seconds. Cool. Okay? So if I multiply acceleration by time, I get a velocity. Okay? Acceleration times time, I get a velocity. Now, on number 4, you've got AT squared. Okay. That's still meters per second squared. But I'm going to multiply it by time squared. So what I'm going to do with the time squared? Put that as second squared over 1. So now what's going to happen?
Second squares cancel out.
And you get
Meters.
meters. So here's the difference. And these are the most common ones. That's why I put them on here. Acceleration times time gets you a velocity. Acceleration by time squared gets you a distance. So there's 2 ways you can get distance. You can take acceleration by time squared, or you can multiply velocity by time. Okay? Velocity by time gets you distance. Acceleration times time squared also gets you a distance. Okay? But acceleration by time just gets you a velocity. Okay? Cool with that. Now, on number 5, I've given you m times m. Do you think I want you to multiply meters by meters?
No,
Why?
because it's mass.
Here's, well said. When you see m as a variable, that's referencing mass. Okay? If I wanted distance, I would have put like x times x, or d times d, or l times l. Okay? So I've got m times m. So this is, and you're going to use this when we get into calculations involving gravity. If we want to calculate the gravitational attraction between 2 objects, we multiply their masses together. So this would just be kilograms times kilograms, which is going to get me
Kilogram squared.
kilograms squared. Okay? Cool with that?
We have square
We're good.
kilograms.
Okay, now, I'm going to jump down to number 1 below. We're going to work number 1, because this is what this whole thing has been leading up to, is question number 1. So, I'm giving you this equation that V V naught T plus A. Okay? So let's say that you're at a party and someone comes up to you and says, hey, are you taking physics? Yeah, cool. What's your favorite equation? My favorite equation is V naught T plus A equals V. It sounds cool, okay? Or nerdy, whatever the situation may be. But, oh, it looks impressive. V naught T plus A equals V. It's a nice equation. It has a nice flow to it. The question is does it actually work? Okay? And again, there's no numbers involved. None, zero, zip, no numbers. It is a process. Okay? Say again, it is a process. So what do you think the first thing you're going to do is? Rhymes with substitute the units.
Substitute
Substitute
the.
the units. Well done. Well played.
Wow.
So,
This wordplay is incredible.
are there any differences in units between V naught and V?
No.
No, because they're just a velocity. This is just your initial velocity. That's your final velocity. Okay? So, come in here and go, okay, this is meters per second. And then I'm going to take meters per second times seconds plus an acceleration in meters per second squared. So then I got meters per second. Seconds cancel out. I get meters plus meters per second squared. So here's the fundamental question. Based upon units, is this a valid equation? Absolutely not. Why?
Because meters plus meters per second squared is not the same as meters.
Yeah, I can't even
Second.
add those numbers together because basically this is not valid because I'm going to try and add a distance to an acceleration and then you're going to tell me I end up with a velocity. Okay? Now again, you all sit there and go, and you giggle and go, don't be silly. We would never try to add a distance to an acceleration and tell you that it's a velocity.
Don't be silly.
You lie, okay? You lie. Promise it's going to happen, okay? But here's the whole point. If you focus on units, a lot of those mistakes, you can put in whatever adjective you want in front of the word mistakes, aren't going to happen. Okay, so let's talk about the backside. Let me give you some hints. So when you get to like number 2, and you have x minus x naught, and I tell you x is any distance. So this is what I don't want you to do. This is what I don't want you to do. If I take meters minus meters, do I get 0?
No.
Oh God, no, no. When you take meters minus meters, what are the units you're going to end up in?
Meters.
All you're saying is that, hey, I'm going to end up in meters. If I took meters plus meters, don't do that and go, oh, I get 2m. We are not adding together variables, okay? Okay? Now, on number 3, when you have 2a, down below you have 2a. Don't even worry about the 2. The 2 will impact your answer mathematically, but it will have no bearing at all on the units. Okay? So don't worry about that. Literally, just don't even worry about it. When you do calculations, hey, we're going to worry about that. When you get to number 7, let me give you a word of advice. You have time equals mv over f. Let me give you a hint. For that force, do not put in newtons. On number 7, you put in kilograms meters per second squared. Okay? Make sure that on number 7, when you do that initial substitution, put in the kilograms meters per second squared. Number 7 is kind of the quintessential, let me give you a hint, multiply by the reciprocal problem. Okay? So on number 7, because you're dividing by this big monstrosity, what I would do is I would recommend that you multiply by seconds over kilograms meters when you actually get into trying to solve the problem. That's going to make life simpler. When you get to number 9, that's a period of a pendulum. It's going to tell you how long something takes to swing back and forth. Does 2 pi impact your units at all? Don't even worry about the 2 pi. Not part of the story. Okay? L is the length of the pendulum. G is your gravitational acceleration. Okay, go and stop that camera again. I got one other thing to hand out.